Okay, so welcome to Physical Science. Today we're going to be learning about chemical change. Last week we learned about physical change. And since that was a few days ago, let's go ahead and take a quick review. But before we do that, just want to point out what our goal is for today. And that is for you to be able to distinguish between physical and chemical changes. This actually is in your notes, by the way. And you'll know that you've got it when you're able to tell the difference between a chemical and a physical change, or in this case, a physical and a chemical change. Order is really not that important. But yeah, so we're going to take a quick review of physical change. And you have this in your notes from last week, hopefully, but if not, you may want to jot it down again here in your notes for today. So a physical change is any of those changes that change one or more of the physical properties of whatever it is you're looking at, the matter that you're looking at. And when you look at those physical properties and their change, it doesn't change the identity of that matter. So the matter doesn't change, just its appearance changes. Something about it changes, but it doesn't change what it is. It's still the same thing. So physical changes, they don't change form, or they don't change to form a new substance, but the substance may have a different appearance. So it might look a little different, but it still is the same thing. For instance, water may go from being a liquid to a solid. It might become ice, but it's still just water. It just happens to be in a solid state. So you might want to jot these down if you don't have them somewhere already. So here are some examples of physical changes. So if you take a piece of paper and you tear it in half, that is a physical change. It's changed its shape and its size, but it's still just paper. Then you have the girl, and she's blowing up a balloon, and that is clearly a change in size and shape, but it's still just a balloon. You also have a car getting smashed by a very large rock. And that is, again, just a physical change. So something about it changed. It changed its shape and its size, but it's still metal that the car is made out of. We then have a coin of some sort that's been bent, so that's changed its shape as well, and it's still actually just a coin. And then we've got melting butter, so that's going from a solid state to a liquid state. So nothing is changing, it's still butter. If you cool it down, it'll return back to its solid state. It might not look the same as it did because it's separated out some of its components a little bit, but all of the components are still there. You can still use it. It's still butter. It still tastes the same. Still smells the same. Still tastes the same. Did I say that already? And then we've got the states of matter. So some of the examples here already kind of pointed that out. But as matter changes from a solid to a liquid to a gas and back, these are physical changes, but they are not chemical changes, because they're still the same thing. They've just changed the state of matter in which they are. If you take a cookie and you crumble it up, it's still a cookie. You can still eat it, even though it's all crumbly, but that is a physical change only. So that ends our review of physical changes. So now we get on to chemical changes. So there are three things that can cause a chemical change. The first one is reactivity. The other is flammability. And the third is cooking. These are things that can cause chemical changes. You might want to jot that down in your notes, as well as the title. You also might want to recognize that chemical matter reacts, and when that happens, a new substance is formed. So we actually create something new from that which existed. And one of the other aspects of the chemical change is that once the reaction takes place and the new substance is formed, it can't be changed back to what it was before the chemical reaction took place. So once it changes, it's changed for good. It doesn't go back. Okay, so you might want to write down that information as well. Here are some examples of chemical changes. So if you burn a candle, the wick is experiencing a chemical change. The candle could be, depending on what it's made out of. Here we have what looks to be a bone with the gray background. And that bone is deteriorating. It's becoming something new. It's reacting with the environment. Fireworks, everybody loves a good fireworks. They are great examples of chemical change. The powders, the elements and compounds that are in the fireworks, when they encounter flame or a spark, they go off and create all kinds of new things. We've also got over here some baking soda and some vinegar, and that's getting all foamy, so that's changing. There's a reaction taking place, so there's reactivity, and it's creating a change, a chemical change. When the rocket blasts off, there's a chemical change going on there in the ignition system, in the rocket system. We'll talk about that in a few more minutes. And then you've got these cooking pancakes going from a liquid state to a solid state, but they're also changing at the molecular level. There's a reaction taking place due to the heat, and something's changing about the pancake mix. So chemical changes can be detected by changes in color, changes in the odor, what it smells like, as well as in what it tastes like. So these are ways that we can detect that chemical changes have occurred. We can look for a color change, a change in what it smells like, or a change in the flavor. Also, if there's fizzing or foaming, that's a pretty good indicator that there is chemical change afoot. We also have the production of sound, or maybe some heat comes off, or maybe it gives off light, or even an odor. So some of that kind of is a little bit redundant, but it's a little bit different. So it doesn't just change color, but it actually gives off a color or a sound, or it gives off some heat, things like that. Okay, last here is the disappearance of a solid. So if the solid disappears, there's a chance that it's a chemical change. Now, if it's just changing state, then it's not really disappearing. It's just becoming a liquid or a gas. But if the solid disappears altogether, that may indicate that a chemical change is taking place. Okay, and again, these changes, these chemical changes, cannot be reversed, especially by any physical change afterwards. Sometimes you can use a chemical change to reverse the chemical change back, but physical changes are never able to change back the chemical change that occurred. And rarely can a chemical change get us back to exactly what we were before, but it's possible. So here's an example of a chemical change, and we had a picture of the space shuttle blasting off in one of the earlier slides. And when these rockets are ignited, they form water as a byproduct of the hydrogen and oxygen combustion. So that water could actually be split back into hydrogen and oxygen again by using an electrical current to cause the reaction to take place. So the space shuttle contains hydrogen and it contains oxygen in gas form. And so they go through a reaction to create thrust. They create, basically it's a highly flammable reaction. So it generates a lot of energy. It's an exothermic reaction, and it causes it causes the thrust that propels the rockets up into the air. And one of the byproducts of that combustion is the formation of water, which is essentially two hydrogen atoms and an oxygen atom, right? H2O. And so we could actually split that H2O back into its component hydrogen and oxygen separated states by using an electrical current. So that's an example of how we can reverse the chemical change. All right, so let's do a check for your understanding. So if you burn wood, is that a physical or a chemical change? Burning wood, if you said it's a chemical change, you would be right. How about crumpling up a piece of paper? If you said physical change, you would be right. How about adding sugar to lemonade? Adding sugar to lemonade. If you said physical change, I believe that's right. And if you boil water, that is a physical change. How about when you fry an egg? Fry an egg. Well, if you said chemical change, you would be right, because the heat that you're applying on the stove is causing the raw egg, the proteins in the raw egg, to denature and become solid. So it makes the egg become solid. So you are actually creating a chemical change there. And when fruit is rotting, what is that? Is that physical or chemical? If you said chemical, you would be correct. And how about removing salt water by evaporation? Well, that is removing salt from water is what it should say. That is going to be physical change as well.